This is the Facit standard calculator. Facit is a company based in Sweden, and from the serial number on the back, 7868, it turns out that this machine was made in 1928. The clever design of this machine is by Carl Victor Rudin. He also designed the later Model T calculator, which was the first pinwheel calculator to use input keys, 10-digit input keys, and had the inverted design where the carriage is the input rather than the output register. The counter is up here above the input, much like a Brunsviga machine, so the carriage only holds the register. This machine was ahead of its time. It's designed very well. The mechanism has a very smooth and light action, so these digits change very easily without much effort. Even when there's a carry involved, it's very smooth. Let's do a simple multiplication of 256 by itself. The units digit of the multiplier needs to be a 6, so I'll turn it 6 times. I've now multiplied this number by 6, and that's here. I can now shift the register one spot to the right to move on to the second digit. And the second digit we need to be 5 for 256. So I'll turn the crank 5 times. And then shift the carriage once more for the hundredths digit, the third digit. That needs to be a 2. So I've now multiplied this input by 256, and the result is 65,536. It has a nice clearing mechanism. This wing nut only needs a half turn. And the same with this one for the counter. Even the input has a very nice clearing mechanism. That's fully internal, and it's this lever here. So shifting the carriage can be done one step at a time with these buttons, but you can also shift it several steps with this turning knob. Unfortunately, this used to have rubber around it, so it's a bit hard to grip now. And you can use this in combination with these tabulator buttons. If I want to move it to position 3, I can keep this down and just give this a turn and it'll stop. It'll be blocked at position 3. And the same goes with all these others. But it is a little bit heavy to turn at the moment. It maybe needs a bit more lubrication, and this grip is hard. The carriage can move all the way to the right for 10 digits, because there are 10 digits in the counter here. The input is 9 digits long, and the register is 15 digits long. The main cylinder in here, however, is essentially 12 digits wide, so it can only do carries over to the 13th point. So if I, for example, subtract 1, you can see it has all 9s up to the 13th place, but yeah, the carry doesn't go any further than that. The mechanism stops here. Nevertheless, you heard a bell. It has an internal bell that rings if it's in this position with an overflow carry or underflow, or in this position. But if you move any further, then it's this bell on the carriage that'll be rung. So if I subtract 1 at this point, it this one should have rung. There we go. Yeah. But if you do it here, it's not this bell. Let's do a division of the usual 355 divided by 113, because that's such a nice approximation to pi. I'll have to clear the counter first, and now we just subtract until we hear the overflow bell, and then undo that last subtraction. Shift the carriage once to the left and continue. There we go. So the result is 3.141592920. As you can see, these digits are not all red. In the subtraction direction they all become red, but the 9s are shared because they're directly opposite the zeros. The zeros are all white as well. So yeah, this counter register does not have carry. Many pinwheel machines were mounted on a wooden board, but this one has a metal stand underneath it. It has this elegant fifth leg on the side to support the crank. That ensures that even if you really put force on this crank, it doesn't lift up the other side, it doesn't pivot. That was the Facit Standard. Thank you for watching.